Hello everyone, and thank you for attending today's webinar, AI Analytics and Automation, the keys to customer experience optimization, sponsored by Guavus. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved. Though we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resource list widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop up on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day of the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading Senior Analyst James Crawshaw. James?
Thanks, Caitlin. Hello and welcome everybody to this light reading webinar, AI Analytics and Automation, the keys to customer experience optimization, sponsored by Guavus. As Caitlin said, my name is James Crawshaw and I'm an analyst with Heavy Reading. And I'm joined today by Stephen Spalisi, who is VP of Marketing and Products with Guavus. In terms of the agenda, I will kick off with an introduction to the topic, and then we'll hand over to Stephen to talk about AI, why has there been so much hype about it recently, what are some of the real-world implementations of AI that Stephen and his company have been involved in, and perhaps more importantly, what's the return on investment in AI, or perhaps what's the sort of payback period, what are the kind of benefits that businesses are getting from their investments in AI that can justify the work and the money involved. I'll wrap up with some brief conclusions, and then as always we'll have around 15 minutes at the end for audience Q&A. So as we go through today's webinar, please submit your questions via the Q&A widget. So the complexity of communications networks just seems to keep on increasing with the deployment of all sorts of new services like SD-WAN, and new technology paradigms like NFV. To meet the ever-rising customer expectations, operators now need to increase the intelligence of their network operations. And the analysts at Heavy Reading here believe that AI and ML will be key to automating network operations and enhancing the customer experience. Now, big data analytics is already fairly widespread in the telecom industry, but this is usually something that's done in batch and then is used to manually update rules and policies. In order to move to more of a real-time, closed-loop type automation, we're going to need systems that are capable of learning autonomously, and that's only possible with AI and ML. Researchers in communication networks are starting to tap into these artificial intelligence techniques to optimize network architecture, the control and management of networks, and ultimately enable more autonomous operations. At the same time, you've got practitioners in the industry who are working on various initiatives such as the Telecom Infra Project's Artificial Intelligence and Applied Machine Learning Group. These artificial intelligence techniques are starting to emerge in the networking domain to address the challenges that we're facing with things like virtualization and cloud computing. And the network automation platforms like ONAP in the future are going to need to incorporate AI techniques in order to deliver efficient, timely, and reliable operations. So what exactly is machine learning? Well, there's a good article by Brian Levy. He's the ex-CTO of Juniper and Brocade in Europe. He wrote an article on the TN Forum website called How Will AI and Machine Learning Impact Communication Service Providers? And in it, he describes AI as the capability of a machine to imitate human behavior. Machine learning, which evolved from the study of pattern recognition, and computational learning theory in AI explores the construction of algorithms that can learn from and make predictions about data. The key words there, learning and predicting. In the article, Levy goes on to explain how in traditional programming, a human writes a computer program and then feeds it with the data, which the computer processes to generate some sort of output. In contrast, as you can see in this diagram here, with machine learning, humans provide the data along with the desired output that they want to get from that data. They give some rules and constraints, and then the computer is left alone to write the program or the algorithm to deliver this. And these two different approaches, as you can see, are shown schematically here. So machine learning tasks can be broadly categorized into three key categories. As you can see in this chart here, you've got supervised learning, unsupervised learning, and reinforcement learning. And I'll just go into a little bit more background on those. So supervised learning, there, in addition to having the data inputs, we also show the system what the desired outputs that we want. So for example, a human operator would choose to do, or what a human operator would do given that input data. What decisions would they make? We tell the computer this is what the human would do. Then we ask the system to create its own mapping of the inputs to the output conditions. So we're not writing a rule, the computer is figuring that out for itself, so that in the future it can act autonomously. Supervised learning can be broken down even further into subcategories, and some examples here are things like regression algorithms that indicate some sort of statistical relationship between different variables, could be, for example, temperature and noise, or classification algorithms that can be used to group observations. So in a telecom context, you might be grouping different alarms in order to help you prioritize them. And after feeding our chosen algorithm with all of the data that we have labeled, we produce a model which can then be used on new unlabeled data in order to make predictions. And a good example here of supervised learning will be a spam filter, where we give it lots of examples of what is spam and what isn't spam, and then we leave it alone to decide on future emails independently whether they are spam or not. And generally these things seem to work pretty well. The next category is unsupervised learning. There, the system is trying to find patterns in the input data, but it doesn't know about any specific output conditions. We haven't told it what's right and what's wrong. An example here might be detecting some sort of weird or anomalous behavior that might indicate a security threat. We haven't told it in advance, but the system has observed and it's seen something as being unusual. The key difference here then is that supervised learning uses labeled training data sets, whilst unsupervised learning has to discover these patterns itself. You've got clustering techniques that are normally applied to unsupervised learning systems. Clustering also designates the input data, like alarms for example, into the different groups, but these groups are not predetermined by a human engineer. So the clustering is generally an unsupervised form of machine learning. Clustering could also be used for anomaly detection, like spotting events that are outside the normal cluster behavior. The last category here is reinforcement learning. And that's an area of AI that was inspired by behavioral psychology. Here the system is given a goal and it adjusts its behavior to try and maximize performance. It gets feedback in terms of rewards or punishments as the system explores the problem and tries to find the optimal solution. And a great example here of reinforcement learning is when they use AI to learn how to play a game like chess. Reinforcement learning is quite good at adapting to dynamic environments where we're not just making predictions based on some historical data, but we're adapting to an ever-changing environment that we're trying to control. The system observes that environment, it takes the actions in order to try to maximize the performance, and then it makes a new observation of the environment, and then takes a new action, depending on whether we're now closer to or further from our desired state or our maximum performance. So in a telecom context, there are various categories where AI could be and is being applied, and I've listed here some of the top ones that we've come across from our research of use cases that telecom operators are working on today. The last one on customer experience management is the one that I want to go into in a little bit more detail now. So customer experience management, for us, it's the intersection of customer service, marketing, CRM, and the service assurance side of network operations and management. And we at Heavy Reading see customer experience management as the process of managing all the various customer touch points to try to ensure a positive relationship with the brand of the operator or the service provider. All these digital touch points are continuing to grow. You can interact on the phone, on a website, through a call center, and analytics and AI are key tools for the service providers in order to try to understand what is the health of the network. Are they getting users complaining on Twitter, for example? Are they able to pick up that information? They also want to be able to follow the customer journey all the way from customer care through to the billing experience that their customers are receiving. And they want to understand what the real-time service quality is that the network is providing. And those are very difficult things to do using traditional statistical analytics. This slide talks a bit about big data in customer experience management. The figure is a very simplified architecture. At the bottom, you've got various data sources. Above that, we've got several analytics engines that are purpose-built for particular data types. A generic analytics engine is unlikely to yield very useful results. You need to be a little bit more specialized. Then above that, we've got domain-specific analytics applications. For example, marketing, revenue management, customer care, network operations. And then at the very top, we've got the various KPIs that these systems generate and track, and that enables management to manage the business more effectively. So customer experience management isn't the end of the story, of course. Arguably for communication service providers, today it's just table stakes, and it's partway through the transformation that they are undertaking. The transformation started many years ago with taking basic network analytics, looking for root cause analysis of problems based on probe data. Everybody has that in place today. The next step was this evolution to customer experience management, where the operators move from just monitoring the network to monitoring the services that are running on top of it. And most of the large operators globally are now at that stage. The next stage, though, that they're working towards is more about modernizing the business support systems that sit on top in order to make it easier for the customer to buy from the operator, and also to make it easier for product management to experiment with lots of new service offerings and bring those to market more quickly. The last phase that we see telcos in terms of their transformation journey, the last phase that we're showing here is the use of analytics to further optimize all of their business processes, enabling on-demand services and making their analytics more predictive rather than just making reactive decisions. Okay, that's the big picture. Let's start off now with an audience question poll to get your views on machine learning and AI. So the question is, within your organization, do you have any network or customer experience solutions installed today that take advantage of machine learning or AI? So either yes, these are generally solutions that you've purchased from third parties, or yes, and these are things that you've developed in-house, or no, you haven't quite got there yet. So pick one of those three answers, and whilst you do, I'll just remind you that you can ask myself and Stephen your own questions, which we'll get around to answering in the last 15 minutes or so of today's webinar. Okay, let me push out the results so that we can all have a look. So interesting that the majority, nearly 70% of you, don't feel that your organization has yet implemented any machine learning or AI-based solutions in the areas of network management or customer experience. I'll just do a quick refresh of that, see if we've got any more responses. So that hasn't changed much, in fact it's gone up slightly. And then the rest are fairly evenly split between those who've either done stuff in-house or bought solutions in from third parties. So it does seem, Stephen, from this poll, that at least our attendees today it's very early days for AI. It's not something that they're currently using. I guess that's encouraging news for you. But is this poll? Would you say this poll result was representative of the industry at whole, or have we tapped into people who perhaps are keen to learn more because their organisations are perhaps lagging somewhat?
Yeah, I think, James, I think it's a fair response relative to where CSPs or carrier service providers are with the digital transformations and their adoption of AI and analytics. I think it's still early days in some regards. It's definitely unlikely on every one of our customers' plates to embark on the customer journey and understanding more about that, improving engagement. But yeah, I would say there are a lot of providers there and currently who are evaluating approaches and technologies in order to tackle these very important decisions as they transform.
Okay, great. Well, I'm going to pass on the baton now to you, Stephen, to take us through the next section of the webinar. I was getting a little bit of difficulty hearing you just then. I don't know if that was my connection. Caitlin says she can hear you fine. So it sounds like the line is good. Right. Please take us through the webinar.
James, thanks for the intro. It's a pleasure to present today on how Guavus is driving innovation and the adoption of AI-based analytics for CSPs through what we call at Guavus the Reflex Analytics Fabric, or RAF. Guavus has been built from the ground up with a single focus: serving CSPs, or carrier service providers. We enable our customers to do more with less, allowing them to drive more value from their data at a lower cost in a much faster period of time. And at the forefront of AI-based real-time analytics and machine learning innovations, Guavus has been driving digital transformation for our Tier 1 MSOs and, in fact, 6 out of the 7 world's largest telecommunication providers to date. Guavus' customers are able to leverage our AI-based solution to analyze massive amounts of data in real time and take decisive actions to lower their costs, increase their efficiencies, and dramatically improve the end-to-end customer experience, all with the scale and security required by the next-gen 5G and IoT networks that are being planned and deployed today. For those of you who may be just starting on your analytics journey, you are likely inundated with messaging from a variety of vendors on how AI can transform your business and allow your teams to do more with less. Now, today we're going to be discussing how AI can improve many of the operational aspects and revenue-generating side of the CSP business. In fact, I have read recently that 99% of CSPs can benefit directly from the adoption of analytics, artificial intelligence, and automation. We call those the 3 A's in order to help transform how they operate. Now, to better understand the possibilities to help you transform your operations with AI specifically, it's not only important to understand the technology behind it, but also the insight into the actual use cases that can drive that efficiency. For example, through things like automated actions, such as a closed-loop action to drive a specific result, or to achieve increased revenue potential per user through understanding your subscribers' behavior. I'm going to be covering some real-world examples of implementations that we've done for some of our largest customers in the world and the transformative results along the way. I'll also be shedding some light on the benefits and opportunities for CSPs by providing practical advice on how to get started today with AI-based analytics. I'll give you a bit of visibility into the return on investment that some of our customers are experiencing from the adoption of these technologies and some of the featured customer case studies and associated use cases. Guavus' value proposition, in a nutshell, is that our software intelligence provides customers insight into how the network affects its subscribers and how the subscribers' behavior affects the network. In both cases, it's about delivering actionable insights all around the customer. The Reflex Analytics Fabric, or RAF, enables real-time decision-making to improve our customers' analytics experience. It requires the use of advanced mathematical models in order to accomplish this. We leverage 2 key approaches in order to achieve greater insights within the CSP's big data. First It's about machine learning, which enables us to make predictions through pattern recognition through the process of training models to teach the algorithm. And secondly, it's all about artificial intelligence, which goes far beyond machine learning and allows the system itself to apply reasoning to gain understanding. In effect, it imitates the human learning process. In order to achieve what's needed for these advanced use cases, you need to move beyond conventional machine learning. Typically, this is done through supervised and unsupervised training. And you need to go beyond that, far beyond, pattern matching and statistical analysis. For instance, suppose you experience a failure scenario that you have never seen before inside your network operations center, and you're asked to interpret this failure and what it might lead to, as well the actions you need to take in order to respond to that new failure. In order to do this effectively, you need reason to interpret that new mode of failure in the terms of all the failures that you've seen in the past up to this point, diagnosis of that new issue, and conclude the nature of this brand new failure. This requires an intelligent learning process as opposed to a pattern-based mapping. Machine learning excels at the latter, but not at the former. This is specifically where AI is needed most. Network operators experience a constant flood of event data every minute, hour, and day. Though a lot of the time, events are informational or benign. However, sometimes they're symptomatic of a much larger issue. False positives often cause operators to intervene and attempt to validate, which means potential distraction and delay. The sheer volume of potential issues can overwhelm any network operations center staff, and these further delays only increase the mean time to understand, or what's called an MTTU. Legacy systems management and monitoring systems often leverage static rules to manage thresholds and alerts. The problem with rules is they often are not easy as a set it and forget it. Rather, they require lots of tweaking over time. Rules are also way too rigid and aren't adaptive. If a new failure scenario is a slight deviation from a known failure, it's very possible that the new failure will be missed in its detection. Lastly, rules don't scale in large environments, such as CSP network environments. Dynamic scenarios such as changes in topologies, change management windows that can complicate things, and introducing new variables. This happens all the time in these dynamic CSP environments. Within our Reflex Analytics fabric, we've developed advanced algorithms that have been designed to derive observations from the massive amounts of network and machine data that we collect, analyze in real time. This includes things like multivariate anomaly detection, autonomous temporal and spatial event correlation, commonality in identification of root cause analysis, behavioral analytics fingerprints such as a heat map of aberrant outliers from devices, entities, assets, and services. We get this incidentally through our unsupervised machine learning. Things like alarm and event classification as well as categorization, and of course continuous learning throughout. Behind all of these advanced algorithms are highly complex mathematical models. The premise in our analysis is to understand the geometry of the data, leveraging the notion of similarity, which means it's measured by closeness within the data itself. It's really important to understand the geometry of data before you apply machine learning. Now, what do we mean by geometry? We need to understand how distinct events are and how they relate to each other, even if we haven't seen one of these events before. We measure the similarity of events by closeness, and therefore we use geometry to do that. The notion of distance is also an important aspect in the process of machine learning algorithms. Conventional machine learning leverages and assumes the notion of flatness. This is as if all events were lying on the same plane. We call this Euclidean spaces. However, the real world is not flat as we know it. There are hills, there are valleys, and therefore you need to measure the distance between the two events by taking into consideration the topology of the map that you're on, if you will. When you view data on a flat plane, two events seem very, very close together or very similar, such as 2 points in a straight line. However, when you see a 3D version of the same scenario, you'll notice that there is a big valley between the 2 points, and therefore the distance between them is much larger. By considering the geometry of the data within our analytics, we have achieved a far greater accuracy, and the outcomes are highly instrumented to solve critical use cases. By leveraging AI and machine learning, we reduce the mean time to understand, or MTTU, which enables customers to resolve their issues much faster and address any potential issues before they could cause an outage or service disruption. We also have the ability to identify impacted subscribers and suggest the next best action. An AI-based approach means the discovery time of issues can be dramatically decreased. Because we aren't a rule-based technology, there is no need to manage or maintain rules. Our ability to identify root issues and the originators of those largest number of issues and how they relate to each other from a child-parent perspective means irrelevant or informational events can simply be suppressed and or ignored in the analysis, leaving the most relevant information to be observed and made actionable.
So indeed, our second poll question for today is in customer service, which do you think is the most important? Would you say it's about reducing the mean time to understand and resolve problems? Is it empowering customer service reps with a complete vision of the customer? They know, what problems they might be having with network. They know if they've been hit with some unexpected items in their bill. Or would you say the more important aspect is applying predictive analytics to preventative maintenance, avoiding problems in the first place by predicting them and fixing the equipment? Or lastly, would you say that the most important aspect is enabling omni-channel access for customers? So, customers, they don't want to call up a call center and complain about something. They want to perhaps go onto a self-serve, self-care app, log a ticket or a complaint, and have it resolved very, very quickly that way. So obviously, all of these things are important. But if you had to pick one, which would you say is going to have the biggest impact for your Net Promoter Score, if you like, or for the customer experience that you're providing? Whilst you have a think about your answer to that question, I just remind everybody that you can ask your own questions of Stephen and of me that we'll get around to answering in the last 15 minutes or so of today's webinar. You can do that via the Q&A widget at the bottom of the page. Some of you have kindly been already using that to tell us about the audio quality, so thanks for that. But do also send through some questions that we can pose to Stephen. Okay, I'm going to push out the results now, see what people have voted for. So we've got a spread of results, but there is a clear winner. Slightly over 50% of you said you thought that the biggest impact would come from predictive analytics to enable preventative maintenance. The next biggest response was for reducing the mean time to understand and resolve problems. And the other two categories, I'm sure they are important, but perhaps they're not the most important. I'll just do a quick refresh of that and see if that's changed the results. No, so it's still the same picture. So predictive analytics, preventative maintenance, that seems to be what's resonating most with the audience today, and then perhaps related to some extent to this idea of reducing the time to understand and resolve problems. Okay, Stephen, if you have got back in, then do shout out. If not, oh, you're back. Fantastic.
Yeah, James. Okay. Sorry about that. I'm back in and on my landline. Great. Those are great responses there. Obviously, everybody wants the magic bullet that allows you to automate the resolution of serious issues or issues even that have not even occurred yet. And in fact, what's interesting about that is we actually have some examples of how AI has been applied in our product to be able to predict things like outages and disruptions of services and been able to proactively reinitiate unlike my telephone call, but proactively reinitiate connectivity or service back so that the subscriber actually doesn't even know that there's a problem. So there's some very slick stuff that's being done in the form of self-optimizing and self-healing networks, and that's very much being driven by analytics and closed-loop actions. So on this next section, AI in action specifically, I'm going to talk about some of those examples and give you guys some real details behind it. These are featured case studies and also the use cases that are associated with them, and they illustrate in many ways different dimensions of what we do in our product, but they definitely reflect what you can do with AI. So let's take a look at what AI gives you the ability to leverage, right? So from a high level, AI provides an ability to cross-relate multiple events that happen in your operation, right? Across diverse data sets that have been ingested at high scale and high volume, and in our case, in real time. In many cases, CSPs require descriptive analytics, like tell me what's wrong, right? Meaning, give me insight into what's happening now and some detail around why. And that's really important. Everybody needs that, right? The aim here is to understand the observation as quickly as possible so that you can reduce the mean time to understand, as many of the folks on the poll had indicated. Now, AI drives more agility into how you operate, from managing the change to automating the closed-loop action, which ultimately will resolve the issue. Now, this powerful capability can drive down costs, and it can also improve how you operate. It even decreases potential investments in capital expenditures. I have an example of that later where they optimize a particular part of the network, and instead of growing or altering the topology, they actually figured out what the problem is, and they actually staved off of capital expenditure and reduced the budget. Lastly, one of the more important aspects of our CSP's digital transformation is to improve Net Promoter Score, right? So it's customer satisfaction, improve customer experience and engagement. Now, in this particular example, a leading cable operator was looking to increase their efficiency for their customer care operation. They wanted to also reduce their overall operating costs. They were very challenged with high internal costs, specifically from truck rolls, right? Each time they dispatched technicians to a subscriber location, it was costing them internally a large sum over time, right? Within the week or the month, it was all adding up. And this is a very large-scale operation, so it's in the millions of dollars per month. Now, from their standpoint, this is before Guavus, they couldn't easily distinguish whether or not the root cause was related to the CMTS cable head-end infrastructure, or if it was CPE related. It wasn't clear to them. And they were consistently swamped with incoming care calls and very irritated subscribers. Now, we came along, and the solution we provided was to enable them with technology, right, through Reflex Analytics Fabric, to correlate network operations and care-related incidents, right? We created a historical baseline based on a huge volume of telemetry and event data from thousands of CPE devices, and we're able to detect anomalies and drill down and pinpoint their root issue. We also took advantage of tying in our software with their orchestration framework to trigger notifications and to automate ticket entries into their care systems. So this is a full closed loop operation. They're seeing the benefits, and they're drilling down, getting the information, and they're actually launching actions to resolve issues. As a result, they decreased their truck rolls, they reduced their operational expense by $70 million, which is huge, right? And they improved the time to understand those emerging issues and problems. The best part, they drove down that incoming call volume for the incidents, and they increased their customer sat by solving those subscriber issues through a combination of highly enabled care reps and online self-service versus sending somebody out to the subscriber's location. So very important, many things that they solved in that particular example. Now, on the mobile side, leading mobile operator was trying to identify potential issues resulting from the change windows and the planned upgrades, right? So they were doing something in their network, they were making a bunch of changes, it was in large scale across multiple sites, many subscribers were going to be touched, their CP related infrastructure. And they were continuously rolling out new updates for their network services. Thousands of devices being upgraded nightly, and though outages were not apparent at first, after a few hours in a rolling fashion, these changes became apparent, and the issues started to bubble up. And they weren't able to track it down holistically, and they were very swamped with frustrated customers, right? So the solution was to deploy our software, our analytics, to enable them to correlate the change activity with those resultant incidents. Our trending and our analysis provided them deep insight into the anomalous activity, which technicians could now monitor as they were changing the network and review that every few hours in order to gauge the impact to their subscriber base. The result was they had, as a result of this, they had greater visibility into the cause and effect, enabling them to even back out changes when they saw errors that were symptomatic and identified through the analytics. By doing so, they could reverse out those potential issues and before subscribers saw the problem themselves. Now, this is that example of pushing that easy button, knowing that with confidence you can reverse that process, and your subscriber doesn't know, and they're no worse for the wear. They don't know they're back online and they're back in service. At this point, they had actionable insights that they could drill down into and expose specifics based on a single subscriber or groups of subscribers, and they could cross-correlate the impact against the associated gear to make, whether it was make, model, firmware, they could do cross-tabulation and understand the potential impacts based on the subscriber pool and the kind of infrastructure that they were connecting through. This kind of level of agility drove up, again, their NPS and their customer sat, and their customer engagement just improved majorly after this particular scenario. James, I believe we have another poll question, so I'll pass it back to you.
Thanks, Stephen. Yep, this is our last poll question, I think, for the day, for the audience. Which objective is most important to your company in the next 12 to 18 months? Would you say it's about reducing CapEx? Would you say it's about reducing operating expenditure? Is it the search for revenue growth? Or are you focused more adjacently on improving your net promoter score? So which of those is the sort of the key message which your organization and its management are driving for? Obviously, again, all of these things are important, and obviously having a good net promoter score is going to be helpful to growing revenue and keeping OpEx under control or customer churn. But which of these four goals would you say is the most important as your organization sees it, or as you see it? Whilst you have a think about your answer to that, just remind everybody that we're going to come up to the audience Q&A soon. We do have one more poll question for our audience, and we've got a bit more a presentation from Stephen to come. So I'm going to push out the results. And we've got a broad spread of responses here. As I said, all of these are important, but it does seem like revenue growth is the key imperative. That's, we can cut CapEx, we can cut OpEx, but you can only cut back so far before you start to damage the potential to actually grow the revenue of the business. And ultimately, that is what your organization's shareholders are looking for, is growth. So it's an interesting takeaway. And with that, Stephen, let's pass on to you, because we're getting to the 41-minute mark. Let's pass on to you for the last few slides.
Sure thing. Thanks, James. And on this point here, I just want to say, in contrast to the descriptive side of analytics, AI can drive the prediction. And this is exactly what the attendees were looking for earlier, right? Just to provide insights into what are going to happen, right? And as more of the CSPs move to adopt AI, analytics, and automation, those 3 A's, having the ability to predict is a key driver for justifying future investments in this technology. It's about making the operation smarter, more agile, and potentially even leaner, right? More efficient. Another area that benefits AI operators is reducing the noise with respect to alarm management and monitoring. Also, tie-ins into orchestration and automation frameworks enable insight into the analytics, and it can perform that next best action closed-loop operation that proactively addresses the issue, right? And all of these benefit the subscriber and the impact to the quality of experience. There's a direct benefit to overall NPS of the service that the CSPs offer, and it'll help reduce the subscriber churn rate, as you mentioned before. This particular leading cable operator sought to improve the responsiveness of managing incidents related to alarm monitoring. They were literally inundated with a flood of daily alarms. They couldn't detect which was serious versus the benign. They were causing their staff to chase new alarms down rat holes, right? So the tools in place that they had were legacy, rules-based style, static analysis, and they were classifying less than 20% of the alarms that were reported. So they weren't even getting a proper analysis of the infrastructure. The solution to the problem was to leverage our alarm classification, our categorization, and our suppression capabilities through our product called Alarm IQ, which is on top of the Reflex Analytics fabric. It leverages machine learning, and it automates the categorization and classification into three broad categories. Those that will lead to an incident, those that are related to maintenance-related windows, and those that are pure noise. We assign probability scores automatically in this process, and we send back the relevant alarms to the source alarm management and monitoring system. So the result is you get a rationalized set of alarms that are highly qualified as relevant and that need to be addressed by that operator. In fact, the system reduces, in this case, over 90% of the alarms for this particular customer, and 2 to 3% of the alarms that they were left with were actually requiring some form of attention. This was huge for them. It improved how the NOC engineers operated and enabled them to cut the noise out and focus on what was absolutely relevant. Best part about it is they could leverage their existing solution. So there was no swivel chair here. They had one solution that was being enriched and being improved through the use of the Guavus technology that was feeding and making it smarter. The last case study I have here is a Tier 1 mobile provider that was seeking to better understand the traffic that was on their network, and in order to make a higher quality experience for their subscriber. They had been previously unable to classify the network in real time. The scale of this network is massive, and to capture all the data and then analyze it, it's just too large. You can't do it interactively. So they were experiencing a major network congestion due to multiple factors. They had unauthorized tethering that was going on the mobile side. There were people that were swapping SIMs out of low bandwidth IoT fixed devices and putting them in other devices. This was a misuse, if you will, from the contractual perspective. There was also a problem with malware on the network, which is causing a lot of the network traffic. With Guavus, we help them deploy our content and behavioral analytics to understand the traffic patterns and what was really being used on the network, which helped them greatly to identify all these irregularities and this high volume. They actually identified that it was a home alarm, an IoT-related connected device that was causing all these variations in network patterns, and effectively what they found out of it was a security threat, where they identified using our analytics certain traffic patterns that were anomalous, that were not normal, that should not have been behaving the way they were. As a result of this, it helped the network security team, and it improved the quality of experience for those who were impacted by the additional congestion and threat. For the tethering issues, they were actually able to create data plans for those, because they knew the subscribers. They knew by analysis who the subscribers were who were misusing the network based on their subscriber behavioral analysis. Using our product, they were allowed to look at that, understand what would be best for that customer, and offer them new plans. So they created an additional monetization opportunity for their offering. The result at the end was the security team could leverage our technology to identify new threats, keep the network healthy. Their network became less congested, and they had a higher availability without adding any additional hardware. In this case, the mobile provider was happy. They improved how they operated, and the subscriber saw immediate improvements. They had the right network, they had the right service, and they were much happier altogether. So that's the end of my case studies. I do believe in the screen here we do have one more poll, unless you plan to move along on it.
No, I think we should be okay. We should have enough time for that, Stephen. So thanks for your presentation. The last audience question poll for today is, in which area is your company most likely to implement an analytics solution in the next 12 months? So do you see that happening in customer care, in the radio access network operations, other network operations, Would you see it happening in a predictive maintenance? Would you see it being used for cybersecurity, for marketing, or for customer experience management? So a wide variety of potential areas. Which one do you think is the sort of the top of the agenda for your company over the next 12 months or so? Let's see what the audience have voted for. We can do a quick refresh. So again, predictive maintenance, like earlier in today's webinar, predictive maintenance seems to be a popular choice, getting slightly more popular there. But there are people voting for all of these different areas. I think that probably reflects a breadth of roles of our attendees. Not everybody is necessarily involved in network operations. Some people perhaps more interested in the customer care side or the marketing side of things. So good to see a diverse range of views about what's important. But there is a clear winner there, and it is this predictive maintenance aspects. Okay, that's interesting. And then, is this? Sorry, is this? Did you have this one last slide, Stephen?
Yeah, just to sum up, just to reiterate from the beginning, Guavus has been focused on obviously big data analytics specifically for tier 1 carrier service providers. It's the bulk of our business is the top service providers in the world, and this opportunity has been great because they gave us insight into how the top service providers operate. We gained a huge understanding of their business, their networks, their challenges, and the needs of their subscribers, who are some of the best customers in the world. The products have been architected and designed specifically from the ground up to handle large-scale ingest and analysis at the petabyte scale, and it's also high performance and done in real time. So it's highly complex variety of data sources, and it's really done at high scale to be able to deliver back these actionable insights in real time. It's built on top of an open big data platform. Our Reflex Analytics Fabric is designed to process this massive amount of volume, whether it be machine data, network telemetry, packet captures from DPI infrastructure, OSS systems, BSS, CRM solutions, and alarms as well. All of that data gives a multi-perspective when you're doing this kind of operational analytics or subscriber-related analytics to get deeper into the patterns of how the operation is behaving or how the subscriber is using the network. Now, with the vast knowledge of how CSPs operate as our foundation, we have incorporated all these learnings into our software, and we're delivering that through AI-based analytics techniques inside the software and algorithms, and they deliver these actionable insights and the kind of outcomes that are required for these stringent environments. With that in mind, our goal is to drive down the mean time to understand and to focus on what's most relevant to help those CSPs maintain and operate their business, which reduces their overall costs and enables them to actually monetize what they know about their network in order to gain better investment protection and analytics. Very insightful stuff, driving improvements in the infrastructure and driving top-line revenue for these service providers in the form of data monetization specifically. Great opportunities there. So James, thank you so much. I appreciate the time today, and it was a pleasure presenting with you.
Great, likewise.
Thank you.
This might be superfluous, but I had also some concluding thoughts. You sort of asked at the start, or you had outlined in the agenda we were going to address why the hype. Of course, artificial intelligence and machine learning are not new topics. There's been plenty of research going back to the 1950s or even before, and in a telecom context I found research going back as far as the early 90s, where researchers were looking at AI techniques that could be used in a telecom networking specific context, and back then they thought that they would actually be essential to the transformation of the telecom network. So here we are 25 years later, still saying the same thing. But hopefully getting a bit closer. The key factors that have led to an acceleration in progress in machine learning in those intervening 25 years are some breakthroughs in neural networking theory. That doesn't apply to all aspects of artificial intelligence, but there were some academic breakthroughs in the early 2000s. Of course, we've had massive increase in computing capacity, Moore's law, We've had the cheap availability of computing capacity through innovations like public cloud. We've had massive data sets that have been available for academics to play with, thanks to things like the web and all of the data that the web generates. And then we've had a number of success stories that have gained attention in the media. I'm thinking there of things like AlphaGo. And in a telco context, advanced analytic solutions using artificial intelligence and machine learning are enabling automation. They're reducing the mean time to understand issues and helping to eliminate or at least minimize the number of outages. We also asked a little bit about real-world AI implementations and the return on investment of AI. That was in the agenda. Well, I think Stephen went through a number of very interesting real-world use cases today. And in terms of the return on investment, again, there were some metrics there. He talked about a cable operator who was suffering with a lot of unnecessary truck rolls. They managed to reduce the mean time to understand problems from hours just to a number of minutes, and that led to OPEX savings of $70 million in the first year alone. He also talked about a multi-service operator that was dealing with a lot of device upgrades that were leading to outages, but outages with a delay after the upgrade had happened. And it was difficult to pinpoint the problems, but with the AI-based solution, they were able to do so more quickly and avert a lot of unnecessary truck rolls and calls into the customer center, and that led to an improvement in Net Promoter Score. And then the other example I remember him talking about was a mobile operator whose network was clogged. A lot of people were using devices tethered to their mobile phones, but consuming a lot of data. And also they were suffering from devices that had malware on them. So unbeknownst to the user, the device was being hijacked and used to carry a lot of data that was clogging the operator's networks. Well, with analytics, they were able to identify the security threats and optimize traffic, and that ultimately led to a higher customer satisfaction. So not necessarily a dollar figure I can put on that, but the first case we had a very clear $70 million cost saving that was quite tangible. So that does bring us to our audience Q&A session. So I'm going to turn to the questions that have come in, Stephen, and let's try this one for starters. So somebody's asking, what's the typical payback period when implementing an artificial intelligence or machine learning solution? So I talked about the $70 million of savings, but I've no idea. I doubt the investment was $70 million. So I'm assuming in that case the payback period was a lot less than a year. Is that right?
Yeah, it's sub 12 months ROI. The systems, pay for themselves and reduce OPEX and CAPEX. The benefits are definitely seen sooner when you've aligned the organization to deliver the right data and the right types and volume of data in order to demonstrate the issue and to show the resolution or the outcome that you're effectively trying to drive for in that use case. So working with our team of specialists, as well as within our product support, as well as our specialists, we have a services group. We can help customers understand which kind of data they need to deliver to us and analyze, and we can expedite that ROI period. But typically it is sub 12 months.
Okay, that's great. I'm going to push out onto everybody's screens, well, I may or may not push out onto your screens a survey. I think last time I looked in my browser, this appeared as a pop-up and was blocked. So you might see something flashing at the top of your browser window. If you don't mind, please click on it and it will open up a new tab where there's a survey, and you can tell us what you liked about the webinar, what you didn't like, what you'd like us to cover in the future, etc., etc. We value your feedback, so please, if possible, do that. And meanwhile, I'm going to go back to Stephen with a really interesting question here that has come through, which what are the sort of complete applications? So we've talked about a lot of technology and Euclidean geometry and things like that, Stephen, but what is the application that the Guavus platform consists of? Is it one module? Is it multiple things? What can you just tell us a little bit about the application?
Sure. Yeah. We have the core analytics fabric, which powers every one of the use cases that I talked about earlier. But as far as commercially speaking, these are use cases which are packaged and sold for specific reasons, right? We have an operational analytics product, which is called LiveOps, which allows you to understand the health, availability of the network operation, and we have this instrumented specifically for the cable industry. We also, in that product, have an intersection with the care organization where we can take information from the care ticketing systems and intersect that with the way that the operation is behaving from a network perspective, whether that be the CMTS infrastructure and the CPE infrastructure together. So you can see a cross-tabulation, if you will, of care and the network operation together, which is really a strong enrichment to understanding how to improve that business. On the network operator side, the provider, a mobile operator, we have monetization technology that looks at subscriber behavioral analytics. That's called Marketing Insights, and that is really geared towards marketing organizations within telecom that want to monetize the sentiment and likes and dislikes and understand their subscribers in order to offer them better products and services, as well as leverage that information from an ad buyer perspective. So there's quite a rich array of intellectual property in Marketing Insight that helps you drive dynamic segmentation so you can better understand at a glance what your subscribers are interested in, and then drive products and services towards those customers. Telecom operators are doing this all the time. Once they understand what a customer is trying to do, then they start to package and sell a service to them. This expedites that process and gives you much more visibility into the patterns and behavior of those subscribers. Those are just two examples. I also mentioned Alarm IQ, which is an alarm categorization and suppression technology that integrates in with IBM's NetCool product. That technology, like I said, is basically like a very seamless implementation that connects in behind the scenes and doesn't allow you to have to switch screens, if you will. It's a very integrated solution. It optimizes the source alarm system. And then we have a number of other solutions which relate to content analytics as well. And I'd be happy to point, as anyone who's interested, point you to guavus.com, where we have all of the use cases and the various products associated with those use cases listed on our website.
That's great. Well, thank you very much, Stephen, for sharing with us your insights today. That does bring us to the top of the hour, and we'll have to ask you to follow up via email with the remaining questions that we've had in from the audience today. It just remains for me to thank you, Stephen Spilisi from Guavus, and thank our audience for taking part. And I hope it has been insightful and useful for all of you. It certainly has for me. Thank you and goodbye.